All right, let's read, continue reading the the key to states of matter. All right, so we're going to be reading to see what causes matter to change. So yesterday we discussed that there are three forms of matter: solid, liquid, and gas. We also learned that a solid of ice can turn into liquid water, can turn into water vapor. Okay, so let's read the article. Let's learn more about these states of matter. When water is solid, you can skate on it. You can put it in your drinks to make them cold. We call this ice. When water is a liquid, you can swim in it, drink it, take a shower in it, or water plants with it. You can fill your dog's water bottle with it. When water is a gas, it is called water vapor. It is the stuff that clouds are made of. Water vapor would never stay in your dog's water bowl. You see, it's as steam from a kettle or rising off a bowl of hot soup. So if we go back and look at this, we have our three states of matter. As a solid, it's ice. As a liquid, it's things that we can swim in, drink, or take a shower in. As a gas, it's the steam that we see from a kettle or hot soup, or even stuff that clouds are made of. There are three states of matter: solid, liquid, and gas. All matter can exist in any and all of these states. Substances change from one state of matter to another at different temperatures. For example, they may melt or evaporate. However, changing the state will not change the molecules. Water molecules are still water molecules, whether they are ice, water, or vapor. And as you can see, I took a couple of notes. So the states of matter change with different temperatures. Okay? The changes in the temperature causes the changes in the state, but it does not change the molecules. Okay? Most substances expand when they heat up. This is because the molecules vibrate more and push away from each other. The amount molecules move is different for solids, liquids, and gases. The most active molecules are in gases, where they are the farthest apart. The least active are in solids, where they are packed closest together. So, an important thing to note is that all substances, when they're heated up, it causes the molecules to vibrate or to move. And at different states of matter, molecules move differently. They're most active and furthest apart when they're gases. They're least active and closely packed together when it is a solid. So let's read about solids. A solid. Molecules in a solid are packed together closely in fixed position. And that just means that they don't really move. They're in that space, they're not going to move. They can only move by vibrating in these positions. So just vibrating in place. That is why solids keep their shape and do not flow. It is hard to compress solids because their molecules are already close together. So they keep their shape, they don't flow because they're tightly packed together. They're tightly held together. Those molecules are tightly held together. All right, so liquid. Molecules, if we look at the picture, we can see that these molecules are kind of more spread apart and they're kind of going, some of them are going in the same direction, some are going in different directions. So let's read why. Molecules in a liquid are farthest apart and can move past each other easily. Liquids can flow and change shape. They can spread out to make puddles. A liquid will fill the bottom of any container it is in. It will still keep the same volume. It will not get any bigger. So the important thing here is that the molecules are farther apart. They move fast past each other easily, which allows for liquids to flow. It allows for a liquid to change shape. And we know this because if we spill water or liquid or milk, it will spread out and make a puddle. And it says a liquid will fill the container. So if you took that liquid and instead of it falling onto the table, it fell into a cup, it will take on the shape of the cup. It will not grow bigger. It will just take the shape of the cup. Here we go. Gases. Molecules. Molecules in a gas are far apart. And even if you look at the pictures, you see those molecules are not as closely packed together as a solid or a liquid. They're further apart. So let's start again. Molecules in a gas are far apart compared to solids or liquids. They can move freely and will fill all the space in a container. It is easy to compress a gas because the molecules are far apart. So in a gas, the molecules are far apart. The molecules can be compressed because the molecules are far apart. Or a gas can be compressed because the molecules are far apart. They fill the space of a container and they move freely wherever they are. Okay. Cool down. When you cool something, you take energy from it. The cooler it is, the less its atoms move. At minus 270 degrees Celsius, it is very cold. It is so cold that nearly everything will be a solid. Molecules vibrate as little as possible. This is the coldest anything can get. It is called absolute zero. No more energy can be removed from something at absolute zero. So when we read this, we learn, a new vocabulary word, absolute zero, which means there's no energy. The energy has been removed. When energy is removed, that means the atoms are moving less. At absolute zero, it's 270 degrees Celsius. It's the coldest that it could possibly be, and it's a solid. So, here's my question for you. What determines water's state of matter? So one of the things that we saw in this article was we saw about molecules and how they move. So what determines water's state of matter? Molecules, movement, and energy determine water's state of matter. All right, boys and girls, here's what you're going to do. You are going to go back in this article. You can look at my video, go back in here, and find evidence that talks about molecules and their movement, the energy that's needed for them to move, to show that how state of matter changes because of it. All right. I look forward to your responses. Once you are finished completing this engaging in the argument from evidence in your notebook, please, sir, please, ma'am, click on the science link. You will read an article independently, and you will come up with an engaging and an argument from evidence about that state of matter article.